August gathering of the Indian Energy Week 2024. And the session for today, and this being the last session, is on digital transformation for decarbonization and efficiency. The session is basically on digitalization, and the digitalization word is basically creating representation of physical objects or attributes which enable or improve processes by leveraging digital technologies and digitization data. Then why call it transformation and not just change? So the difference between the two words is change is basically a small step or a change which is replacing something which is existing, whereas a complete change is the digitization. So digitalization transformation is really business transformation and enabled by digitalization. For over a century, the industry has played a vital role in the economic transformation of the world. But today, as the industry is on the cusp of a new era with new challenges, we as an industry are not new to volatility. And there is a constant pressure on us to reduce cost, increase efficiencies, and adapt business models to remain competitive. However, these pressures are gaining greater prominence on the energy transition, building momentum and competition from alternative energy sources. Development of the internet has connected people, organizations, and businesses on a scale that could not have been fathomed a few decades back. This connectivity has rapidly extended from themes such as equipment, devices, sensors, controllers, actuators, and now it is not only connecting them, but making us available with statistical tools, machine learning algorithms for analyzing the data and using the data effectively. With the IIoT being nicknamed as the intelligent Internet of Things, our industry has entered an era which is linking big data, machine learning, and analytical tools with wireless network to physical equipment, transforming the way we monitor and desire benefits from our assets. The industry, especially the large ones, once generated a reams of data, which gets siloed and not used after a certain period of time. Now is the time to break these silos and use the data which is available with us so that we can basically leverage this, identify correlations and patterns in data which otherwise would not have been possible manually. To overcome this challenge, many companies have broken down the silos by collaborating with technology providers. Once we can consolidate this data, the next generation digital solutions can be employed. Hence the endeavor so that this huge data which is available not only remains as a part of the dashboard, but can be transformed and leveraged for intelligence use in predictions and safeguards. So we begin today's with our speakers who have consolidated this data and leveraged it for intelligence use. One of the speakers will not be possible to be available with us because of some family exigencies. So I will request the second speaker, which is Mr. Satyanarayan Arunachalam from Reliance Industries, to take us through the digital transformation in the downstream. Mr. Satya.
Very good afternoon to you all. Yesterday is the history, tomorrow is the mystery, and today is the opportunity. How to leverage history data with latest digital technologies to create sustainable success is the challenge for all of us. Here I would like to acknowledge the contributors of this presentation, Mr. Jessimalli and Mr. Suraj Tipirneni from Technology Department, and Mr. N.C. Chakrabarti, one of our co-chair of this session, and Mr. Akhilesh Kumar from Smart Manufacturing Technology Department. This is a corporate disclaimer statement. The scope of this presentation is strictly for knowledge sharing purposes. Reliance has the growth platforms across energy, consumer, and technology businesses. And we are maintaining a prominent role and leadership in Indian corporates for almost 3 decades. And we are having number 104 rank in Global Fortune 500 company, and we are well positioned to take care of all future growth opportunities. Now, let us come to digital transformations. Reliance Jamnagar, having 2 ultra-large refineries, petcoke gasifications, and refinery off-gas cracker petrochemical complex is always the front runner in adopting latest digital technologies. We are in the process of deploying a unified digital platform by integrating all the domain expertise with appropriate interfaces. It will unfold our productivity by simplifying the process, automating the task, and breaking the digital silos. It will enable us to improve our efficiency, safety, and reliability. Our digital elements, starting from plant digital twins, CCTV, handheld, smart devices, and virtual assistants, will unlock our potentials. Now, let us focus mainly on process digital twin, how it is giving the value addition to the corporation. See, process digital twin will facilitate the real-time optimization for improving the operational excellence and will bring out the hidden opportunities in the system. It will give the precise view of all the operational performance and constraints. Real-time monitoring of process, equipment, energy, and advanced process control will enable us to identify the gaps and rectify those gaps then and there. For example, it will give the best insights of when to change the catalyst. Considering during the end of run conditions, it will be associated with increase in the utility consumptions and deterioration in the product yield pattern. So considering all this, whether advancing the catalyst changeover is beneficial or not, if it is beneficial, when to change over those catalysts, everything we can absorb from the real time. And real-time data analytics model having early event detections, prescriptive model as well as a predictive model will help us to avoid the process upsets and process interruptions in the real time. Similarly, reliability models will help us to avoid erosion and corrosion issues. Having the faithful steady state model will be able to help so many doing the what if analysis in the offline. For example, identifying the alternate feedstock, whether we can process the same thing in our existing infrastructure to improve the profitability. Similarly, change in the operating conditions, whether what are the things to be changed if the change in the product grade or product specifications over the period or its prices. And we can do the debottlenecking studies for capacity improvement. So all these benefits we can derive from the digital twin. Let us see how to explore these benefits. See, the term digital twin is unanimously used across the industry for different understanding. For a continuous manufacturing industries like refinery, process digital twin means it is the digital replica of all the unit operations in the plant, which includes chemical reactions, separations, and heat transfer in the form of models to get valuable insights. We can use first principles or hybrid or AI and ML models to generate the or mimic the actual performance of the process unit. It will give the desired business objectives like operational excellence, safety, and reliability. To mimic the actual operations, there are multiple model needs to be built. There are three key elements for each process digital twin for the each unit. The heart of process digital twin is the process simulation model. It may be based on first principles or it can be augmented by using the hybrid versions. It will give the real-time insights in the process units, which will help the operation team and technical team to improve the gap in the real time. For example, since it is giving all the results, operator need not wait for the lab results to get the corrective actions. Next one is data analytics model. Data analytics model is based on the data science models inbuilt with algorithms or AI ML techniques. Yearly event deductions as well as prescriptive analytics are the common examples for this data analytics. And equal important is the interactive dashboard. It integrates the highly quality data and value-added information generated from both process models as well as data analytics model in the best visualization mode and to take the faster decision making. It will also generate alerts and recommendation for the operations team to take the decisions then and there. Now we will see one by one with little examples so that we will be able to understand and appreciate the importance of those models. For a given feedstock, getting the right products at right specification and right quantity with minimum energy consumptions are the challenges in the energy management field with reliability and safety. We'll take the example of distillation column, which is widely used unit operations in the refinery. Here, for getting, we might have incorporated advanced process control system to have the minimum energy consumption for getting the desired product quality for the distillation column. But how APCs operates? For getting the minimum reflux ratio and with respect to the product quality, it will try to adjust the reboiling duty. Whatever the minimum reflux ratio within the prescribed limits is the real optimum or not. For that, we need real-time simulation models. Real-time distillation model can be built based on the generic model available from the vendors. It can be customized based on the hardware details and it can be fine-tuned using the actual performance of the units using the test and report as well as the on real-time lab reports. With that, we can fine-tune and make the distillation model. Once the model is deployed, it will try to give real-time insights of the process units, not only about right reflux ratio, but also it will try to give all the valuable insights. What are those valuable insights? For example, it will give stage-wise hydraulics, whether unit is within operating range or it is going to hit the operating range. If it is going to hit the operating range, what are the parameters to be adjusted to overcome those constraints? Everything can be inferred from these real-time insights. Not only within the column or within the distillation column, but it will also give the very much other insights also for downstream, either downstream equipment or downstream process units. For example, if there is a compressor, if you know the composition and properties of those feed stream in real time, we can calculate and monitor the performance of the compressors. For that, earlier, if you are not having this real-time model, we will be relying on the lab results, and with that old lab results, we'll try to calculate that compressor efficiency. But now having this real-time feed summary, in real time we can monitor the performance of the compressors. This is for the equipment. But at the same time, for example, in crude unit, if you are having the quality of atmospheric gas oil as well as the vacuum gas oil, it can be used in the downstream processing unit so that we can optimize the severity of those hydrotreating or hydrocracking unit as well as the better hydrogen manage to optimize overall plant of the refinery. This is how our digital twin model, process model, is helping us to reach and sustain the optimum operations of the process units. Similarly, we will see how this data analytics model is helping us to improve our performance. See, application of process data analytics have been evolved over the time thanks to the new generation information technologies like IIoT, big data, and as well as AI and ML techniques. It has evolved from descriptive analytics, that is, it is mainly focusing on what happened. Then further to diagnostic analytics, it is based on why it has happened. Now we are in the era of making this predictive analytics, that is what will happen in future. And the next step is that prescriptive analytics, what should happen, then I can save my plant and improve the reliability of the equipment. Even this prescriptive analytics, there are two variables. One is decision aid, another one is the decision automation. This decision aid still requires the manual intervention to make the corrective actions. But for if you are in the decision automation mode, we can directly into the actions without the manual interactions. Our endeavor should be such a way that without manual intervention, how to automate all those things till we are taking the corrective actions in the field. That is how the concept of data analytics. Now we will see with live example. See, for developing the data analytics model, first we have to finalize what is the use case we are going to adapt. So depending upon the use case, there are number of technologies are available in the market. So according to our use case, we can select which is more appropriate for that use case. Once use case is selected, now we have to gather the data. First, we have to identify the data set which is closely representing the use case scenarios. Once it is selected, then it can be uploaded from the imported to the system. Data may be from single source or multiple sources. Once data is taken into the system, we have to analyze for whether any correlation is available or not. So before that, there was one more step, that is data sanitation. If we have to analyze the data, whatever the data we are given is correct, or is there any outliers. If there is any outliers, we have to screen it and clean it. So then next is analyzing the correlation among them. Once we are able to identify those correlations, then we can segregate or cluster into multiple operating zone, which is under which condition it is healthy and which condition it is not healthy. So like that we can make the cluster. Once we are making the cluster, now we can see the clear difference between what is good and what is bad, and what are the parameters influencing those good or bad. Once we identified those variables and their interactions and their dynamic behavior, we can build the final dynamic model. That data analytics model, once we build, it will try to give you are operating in the which area and what are the operating range you are operating, what should be the operating range, so that you will be always remaining in the healthy status. It has been incorporated in our Reliance for many use cases. For example, one use case I can tell, we are having a petcoke gasification unit. Their run length of critical equipments are always the concern. By using the first principle model is also a real challenge for that. So what we have done is, we are having a smart manufacturing team. They are very much specialized in developing this data analytics model. That is being currently headed by our co-chair, Chakrabarti sir. So what they have done is that they have done this analytics for identifying what are the parameters is influencing the lower run length of the equipment. Then they have collected all the data and they have segregated under which circumstances it is giving the lower run length and which circumstances it is giving the higher run length. So by segregating and analyzing each zone critically and evaluated, and they have identified what are the parameters are causing those lower run length and what should be done to improve the run length. All the parameters with their operating range, now operator is able to see which operating range he has to operate. See, because at a time, one parameter or two parameter operator can easily concentrate and take the corrective action. Since it is the impact of multiple variables, that too for multiple equipment, models like this data analytics is really the key intake for data analytics. And this for Reliance, process digital twin is a result of collaboration among multiple departments across Reliance. We are having the clear-cut strategy for developing this process digital twin model for all the process units in coming years. With this, I am concluding this my presentation. And my sincere thanks to Energy India Week for giving this opportunity. Thank you. Thank you very much.
Let us invite Mr. Raman Singh from Singh, please.
Yeah, hi everyone. Good evening, and thank you for having me here. So we'll go with the presentation now. This is a disclaimer which I think Satya has already shown it, so it's just for a learning purpose. I'd like to thank the presenter who have really contributed it. Out of this, only one traveled with me here in Goa. Akshat, who is sitting in the front row. Thank you so much for coming. So PTM is not a new word in the industry or in Shell. So what I'm going to talk about is how we do and what we do actually in Shell. So PTM is actually in this session, we'll be more talking about the advanced analytics, what we are going to use for the PTM and how it is enabling the next form of monitoring. Yeah. So on the how part means how we are doing it. In 2018, Shell has set up a 2 COE, Center of Excellence Center one in US, New Orleans, and another one is in Bangalore, where I belong to. And the purpose of setting up this is not just a monitoring of the used equipment, but also standardizing the monitoring all across the Shell asset. And currently, we are monitoring almost 25 plus assets from the monitoring centers, which really a key enabler for reducing the carbon emission and increasing the reliability of the units. Yep. Out of this, we have a discipline engineers which used to do the monitoring instead of what operator monitoring is. There's a big difference what operator monitoring and what our discipline engineers do. We also have a different analytics what we deploy. I'll be going through it as we go up. And then these are the analytics which we normally use as a third-party vendor tools, where you can see there is a rule-based algorithm, which was a traditional ways of doing monitoring, a simple threshold monitoring, putting it in the Excel sheet. If the limits are breaches, we used to get the alert. We try to mitigate those challenges. Now we have changed our perception from simple threshold monitoring to new advanced rule-based surveillance, where we have the analytics which can tell you the multivariable comparisons, where you have one analytics which can show you, this is some problem statement is how this has came in, the recommendation has been provided. Suppose a parameter is deviating from the baseline, immediately you'll get an alert instead of it is hitting the limits or the alarm. Next one is two variable if they are drifting apart. Then also we have those analytics developed where we can at least get all those alerts in the system. Now once those alert comes in, what exactly happen next? So those things, actually we follow a exceptional based surveillance workflow, and currently where we are in Shell is, this is our steps where we are increasing towards the autonomous operation. So first thing I was talking about manual monitoring, which is actually couple of assets still in Shell are doing manual monitoring. Apart from that, we have a partial automated system where we have developed the new generative AI things as all. And then we have an automated rule-based system. Yeah. So most of the assets in Shell are lying between 2 and 3. As we are evolving and the assets are getting smarter, tools are getting smarter, we still have few years where we can at least develop ourselves from 4 to 5, where we have a self-diagnostic plant or maybe autonomous operations, where each and every alerts, whatever is coming or recommendations are coming, they will be transformed into a work orders, SAP system will be integrated and all those stuff. So we started this with most painful point in our system is rotating equipments. Apart from the rotating equipments, we now have so much of support from these monitoring centers in wells, in process systems, in many of those other disciplines where we can support asset at all. So this is the typical workflow which I was talking about. Once the alert comes in, what exactly we do? Means the real-time data, we took it from the PI, we used to put it in our event detection tool, where we have all the advanced analytics deploy. We get those alerts in the system. Once if it is a real alert, we start processing into the workflow management tool, which is exception-based surveillance. Once that data put it into the exception-based tool, it will directly go to the first level of monitoring from the engineers, junior engineers, which is around 2 to 10 years of experience. They used to go through it. They'll try to do the first level of analysis and provide their recommendations. Then somebody like a specialist or SMEs, those who are sitting at the monitoring centers, they'll just go through it and see, these are the things which we need to tell to the engineers. And then the engineers sitting into the asset, they'll start working on it. Once they have those working or they have some new findings, we have a learning loop as well where engineers will provide their comments, and these are the things which we did finding. So now the two USP of having the two monitoring center is, first one, it reduces the load on the engineers. And the second one is the most important thing, to standardize the work process across Shell. So if we reduce the workload on the engineers, they'll be much focusing on the value delivery part and the action, whatever has been recommended by the monitoring center as well. Now the next generation thing what we are working on is integrating all the tools which is available across Shell to at one platform in the digital twin atmosphere, where we have all the data available. We'll be integrating all those tools across a same platform, so that at least if we have some alerts or some anomalies, what we do is we have to switch to the different screen, different tools to just dig down and find out the condition, what exactly it's happening. So with this enabler in the future, what will help is all these data will be at one point. People don't have to go to the different locations and try to find out the anomalies and recommendations. So with this, we have also introduced generative AI thing, where we are actually putting what is the problem statement, what are the possible recommendations, and by what time this is going to be having a deferment or maybe a failure can happen. So those things Shell is working on. Still it is on the conceptual phase, and I believe that this is going to be a change maker, where people from different locations are sitting together and they are integrating together with the tools and all. With this, I just conclude my presentation. If there's anything, I'll be okay.
So now we'll invite Mr. Aditya CP. Please.
Good afternoon, ladies and gentlemen. Thanks for giving me the opportunity to present at this venue. I'm honored to stand before you today to present a transformative journey undertaken by Hindustan Petroleum Corporation Limited Visakh Refinery, a journey that embodies the convergence of innovation, technology, and a steadfast commitment to excellence. Without further ado, let's delve into this case study on creation of digital assets and its impact on efficiency, which is carried out as part of the digital transformation journey of Visakh Refinery. Let me start with a brief introduction of our corporation. Hindustan Petroleum Corporation Limited is a Maharatna company in the energy business with two major current running refineries, one on the west coast, which is Mumbai Refinery, and another on the east coast, which is Visakh Refinery. Visakh Refinery is a refinery which is set up by Caltex Oil Refining India Limited in 1957 with a capacity of 0.675 million metric tons per annum. It was then taken over by Government of India and then merged with Hindustan Petroleum Corporation Limited in 1978 with an installed capacity of 1.5 million metric tons per annum. So this capacity over a period of years, in 1985 and 1997, we had two major expansions. And then in 2005 and 2013, we had clean fuel project for meeting the BS6 norms for MS and diesel. So through these expansions, it has been expanded to 8.3 million metric tons per annum. And in the last year, through commissioning of our modernization project, it has come from 8.3 to 15 million metric tons per annum. So as I was saying, in this last 6 decades, our refinery has undergone multiple expansions. There have a lot of new units have come, as well as the existing units also have undergone revamps in multiple phases. Sometimes during the major expansions and sometimes in the middle of the major expansions. And as we all know, all this hard copy of the final project documentation, until the late 2000s, it was in the form of hard copies. So we were receiving hard copies in silos for this in these projects, as well as even for the revamp of the units. We were unable to correlate whether we are receiving the complete as-built documentation for these units or not. So this over the period, even the units, all these units have undergone changes internally through MOCs and internal revamps. So which may or may not have been reflected in the as-built documentation. So in fact, we have faced one of the issues that in 1997, due to an unfortunate accident, what happened was we had lost a major chunk of our as-built documentation at that point of time, which later caused major challenges in carrying out our regular maintenance and operational activities. over the past 2 decades, we were able to capture and get all this as-built documentation like the process data and engineering data through multiple activities, using conventional activities basically, like taking the measurements from field and approaching OEMs for the data. So, but even then, we have found that it is not a scope of like just tens or hundreds of documents. It is a scope of tens of thousands of documents. So this created a lot of challenges, like this documents when scattered form in person dependent manner. Like for example, if I want a process data, I have to approach the process person. When it's related to inspection and maintenance, I have to approach the respective persons. Like we were able to consolidate the major data into one location, but it was still creating a challenge. And there was lack of clarity on the completeness and correctness of the documentation. These MOCs were not always updated. And the storage of as I was saying, storage of information in hard copies takes up space and can be prone to damage. Further, because of this, there was a long lead time for retrieval of information, so which was leading to delays in taking decisions. So in order to address all these issues, we have decided to carry out digital transformation of our asset information management. We have gone about this in 3 ways. The first way is creation of digital assets. By digital assets, we just mean the digital representation of the physical assets. So these digital assets are like intelligent 3D models, smart P&IDs, documents, and the master tag database of all the tags pertaining to the refinery. So the intelligent 3D models, the term intelligent basically means the 3D model, all the assets are tagged, and the entire information of each and every asset can be obtained from the 3D model itself. So, and also this 3D model is dimensionally accurate as it has been captured through laser scanning activity. Further, what we have done is over the last 40-50 years, for all the legacy units, we have observed that the existing P&ID and the field condition were not matching, and in some situations we found that they were been varying by more than 20%. So in order to address this, we went about creation of intelligent process and instrumentation diagrams, which is P&IDs in short, and to ensure that this smart P&ID represents the as-is field condition, we have first verified each and every line of the field with the P&ID and then converted it into a smart format. Further, then we have integrated all these digital assets so that they can talk to each other in an intelligent format. The second initiative that we have taken up is the creation of digital assets that I have talked about earlier. We have done for the legacy units. For the modernization project that we have been undertaking since the last 6 years, what we have done is instead of going about this in the reverse engineering way, from the beginning itself, we have ensured that we will be getting all the data in a digital format in a proper platform. So what we have done is we have implemented an asset information management solution called Electronic Project Data and Document Management System to host all the digital plant information in a single platform. This platform is hugely scalable, such that even if the refinery is again doubled in capacity, it will be able to take the entire data into the same platform, and it is very seamless and easy to access, so that any user at the touch of a button can access the entire data of any asset in the refinery in a single dashboard. In a single dashboard, he will be able to see all the attributes of that asset, the 3D model of that asset, and where it is located in the field, all the documents, the purchase data, the history of that asset, as well as the P&ID. It is basically a central repository for all the asset information data. So this solution we have come up as part of our modernization project. The way we have gone about it is, so we had multiple LSTK, lump sum turnkey vendors carrying out the expansion project for us. So we initially came up with a set of rules that we have set up in the system, so which conform to the requirements of a refinery. Like what are the necessary attributes that have to be there for a certain class of equipment, and what kind of data it has to contain. So any data that the LSTK is giving to us, it first flows through this validation server containing these rules. So once this document, it is ensured that this document or data satisfies all the rules, then it has been put into the production server where it is accessible to all the users. Another small initiative that we have taken up apart from these two is due to that 97 incident, we have lost a lot of as-built equipment drawings, equipment J drawings for our old legacy units. So this during the last few turnarounds, what we have done is we have used this coordinate measuring machine for reverse engineering of all the equipment components in an accurate basis. So we have captured the scan data, individual scan data for all the components of the equipment. We have generated the 3D model, and from that we have extracted 2D drawings, which will be later be used for all the maintenance and procurement activities. Through this journey, transformational journey, we have unlocked multifold benefits in the terms of first, we are able to increase the reliability and accuracy of our documentation, enabling increasing increasing the efficiency of our operations. This 3D model that we generated through this process of laser scanning has an accuracy of more than 99.5%. Further, this activity has enabled us to enhance our design and engineering activities through enabling quicker engineering of large-scale projects and revamps. We have actually observed almost 25 to 30% reduction in engineering hours because of this activity. Further, these intelligent 3D models can be used have been used by our maintenance team to accurately fabricate piping spools and in-kind replacement of equipment. Thereby, we are able to beat the turnaround schedules and shutdown times in time. This is further benefits we have achieved is decrease in lead time for gathering information. So we were able to take timely decisions for operating. To summarize in general terms, previously the information was available in a scattered manner, and there was high lead time for gathering the required information for taking timely decisions. There was low clarity on whether the information that we have is complete or not, or it's up to date. And it was all these things were leading first for the increase in time for the initial activities for projects. So now after carrying out this transformational journey, we ensure that information is available in a centralized platform at the touch of a button, and we have observed a reduced lead time for gathering required information as well as high clarity on information completeness. This has led to us being less prone for project delays, reworks due to improved information reliability. The unique feature of this initiative is what we have done is basically a digital transformation of our asset information management. Now, our next step in our journey is to integrate this with other digital transformational initiatives that we have taken up in our refinery, such as process digital twins, maintenance systems, ERP systems, as well as asset performance management solutions. So we have ensured that this platform is capable of integrating with all these systems, and also it is able to integrate with the engineering data of any format. So it is basically format agnostic. This platform is very easy to access, and users need not have a high learning curve to use this platform. Apart from this, we have carried out other initiatives in silos by various teams in our refinery. One is that online corrosion monitoring through industrial Internet of Things based sensors. So these sensors are mounted on the equipment, and they monitor the real-time health of the equipment, such as temperature as well as thickness. So because of these sensors, actually in 2021, we were able to avert an unplanned shutdown for our FCC unit by taking timely preemptive action. We have carried out a small demo of virtual reality based operator training simulator for our full conversion hydroreactor unit. So this operator training simulator, it is helping our trainers to train in a safe and free environment before working in the actual plant. Also, we have carried out a small demo of our augmented reality based technology for maintenance support, where any maintenance engineer, while carrying out overhaul of a pump or a motor or any equipment, he will be able to get visualized assistance for the step-by-step operating procedure for carrying out this maintenance. Also, in field, he will be able to remote access the subject matter experts or OEM for taking assistance. And for our last couple of turnarounds, we have done, we have used a connected workers based platform for real time monitoring of turnaround activities and delegation of duties. Having done this, for unlocking further value for this platform, we intend to integrate this asset information management tool with digital twins, with maintenance platforms such as ERP and asset performance management tools, as well as we intend to use remote collaboration tools for unlocking efficiency. That's it from my side. Thank you.
Let us conclude. I would like to thank all our speakers. So the session today, we found we saw many embracing many technologies. Mr. Satyanarayan Reliance talked about where fundamental physics, chemistry, and thermodynamic based model meets the database model to create more value to the organization. Mr. Raman Singh from Shell talked about the predictive technical monitoring, which embraces the technology of AI, ML, and he also mentioned about the large language model application in our industry. Similarly, Mr. Aditya Sankar talked about their journey application of AI, IIoT, and also mentioned that there are number of unplanned shutdown they could avoid by using these technologies. So the transformations is not easy. There are bends and obstacles across the path, but the collective brilliance of mind is going to illuminate the path of transformation. With that, I would like to thank all fellow innovators here in this room who listened to the presentations, and let's the journey begin, or let's the journey continue, and let's continue to embrace this technology in our field. Thanks to everybody.